Great. Great. Well, welcome everyone and good afternoon. This is the May webinar hosted by the National Ag Producers Data Cooperative Steering Committee here at the University of Nebraska-Lincoln. I'm Liz Lorang, a member of that steering committee and an associate professor and associate dean in the university libraries at the University of Nebraska-Lincoln. Along with my other steering committee members, Jennifer Clark, Trenton Franz, Matt Spangler, Joe Luck, Laura Thompson, and Hongfeng Yu, I'm delighted to have you with us today for a presentation and discussion with Dr. Harvey Blackburn. And I'll introduce Dr. Blackburn and his presentation further here in a moment, but I first wanted to share a little bit more about the National Ag Producers Data Cooperative, as well as a funding opportunity, and also cover a couple of housekeeping details. The National Ag Producers Data Cooperative is a result of the FY 2021 Consolidated Appropriations Bill, which included a general provision that required the National Institute of Food and Agriculture to develop a public-private cooperative framework for data repository solutions to curate, steward, preserve, share, and leverage the data generated by various technological advancements in the agriculture industry. The data framework should enable land-grant universities, nonprofits, and small businesses to partner with national and regional producers to support the development of advanced technologies and sustainable, profitable practices to meet the increasingly complex agricultural challenges of farmers and ranchers. At this time, the goal of the National Agricultural Producers Data Cooperative Project is to gather essential information needed to inform such a cross-domain and cross-community data framework, one that can support a grower lake across diverse national and regional agricultural systems. We know that many efforts exist in this and related spaces, and we're seeking to learn from existing and allied efforts. Our webinar series is a part of our work to ensure diverse participation, including all types of agricultural research institutions, producers, small businesses, and representatives of relevant producer and consumer organizations. So although the steering committee is based at the University of Nebraska-Lincoln, when realized, the Ag Data Cooperative will stretch far beyond any single academic or other institution. In support of that vision, then, we're also seeking applications to support and enable national, regional, or domain-specific stakeholder groups to host meetings and encourage broad and diverse participation in developing that blueprint for the framework. So we have a current funding opportunity, and I will put the link in the chat here in just a second. We invite proposals for that funding that will allow us to contribute to the development of the cooperative and especially encourage projects that broaden interactions across communities. Proposals are due June 1st, and although that's coming up, we're happy to talk with you about how you can still submit for that June 1 deadline. Let me stick the link in the chat. So as we turn to the presentation from Dr. Blackburn, I would just ask that you make sure your microphones are muted. We are recording the webinar, so you may wish to turn off your cameras during the presentation, but that's up to you. Dr. Blackburn is open to fielding questions during the course of his presentation. So if you have questions during the presentation, please use chat for that. Jennifer and I will keep an eye on chat and let Dr. Blackburn know that those questions are there. During the fuller Q&A portion, you can ask questions via chat, use the raise hand feature. We're a small enough group that you could simply unmute and ask your question as well. Just ask that the first time that you ask a question or prior to speaking that you introduce yourself before doing that. So now for today's main event, genetic security research and resources, acquiring, evaluating, preserving, and distributing critical genetic resources. During this presentation, we will learn about the U.S. Agricultural Genetic Resources Preservation Research Unit. This unit, located within the Center for Agricultural Resources Research in Fort Collins, Colorado, provides genetic security to the agricultural production and research communities by focusing on the acquisition, evaluation, preservation, and distribution of critical genetic resources, including plant, animal, insect, and microbial material. For example, the unit plays a critical role in several USDA national programs, including the National Animal Germplasm Program and the Plant Genetic Resources Genomics and Genetic Improvement Program. Joining us today for this presentation, we have distinguished researcher and leader, Dr. Harvey Blackburn. In 1999, USDA Agricultural Research Services established the National Animal Germplasm Program in Fort Collins, at which time ARS named Dr. Harvey Blackburn to be its coordinator and in charge of collection development, a position he has held since that time. The primary mission of the program is to conserve U.S. livestock genetic resources through gene banking gametes and various tissues via cryopreservation. Since the program's initiation, the collection has grown from 0 to over 1 million samples collected from over 60,000 animals. The structure and processes employed by NAGP were developed under Dr. Blackburn's leadership, including the web-based database Animal GRIN, which has been developed jointly with Canada and Brazil. In developing NAGP, Dr. Blackburn has interacted with a broad range of private and public sector stakeholders. As a component of his current position, he has represented the United States at the Intergovernmental Technical Working Group on Animal Genetic Resources of the Food and Agriculture Organization of the United Nations, where he was twice elected chairperson. Working with FAO and other OECD countries, he led the first workshop on gene banking livestock species in Tunisia. 15 sub-Saharan African, Northern African, and Central Asian countries participated in that workshop. And within the US, he has worked with several groups on processes for developing biological collections and conserving genetic diversity. In particular, the USDA, the National Oceanic and Atmospheric Administration, and the US Fish and Wildlife Service. He has served as an external reviewer of the European Union's Horizon 2020 project on gene banking and genetic resources. He has authored and co-authored over 100 peer-reviewed journal articles. These include the development of FAO's guidelines on cryoconservation of animal genetic resources, ARS collections providing the foundation of science, status report, and strategic plan, the Council on Agriculture Science and Technology's reports on animal agriculture and global food supply and protecting food animal gene pools for future generations. And I could go on and say much more about Dr. Blackburn's efforts. I'll conclude there for now by way of introduction. And Dr. Blackburn, over to you.
Thank you very much, Liz. You should see my screen at this point. Anyway, thank you very much for the opportunity to come and visit with you all today about what we do at the National Animal Germplasm Program. Points as we go along, what I've chosen to focus on, given kind of the nature of this group, is really how we went through and developed our database system. So this presentation will be kind of heavily focused on that, but certainly we can go into any aspect, other aspect that we're dealing with during our discussion here, that if you have an interest in going there. The other thing that let me just kind of note is that as we go along, you'll see, like in the lower left-hand corner of this slide, some other slides, some images. Those images are actually from our Animal GRIN database, the public-facing aspect of it, and so it maybe gives you a little more flair or flavor for what that database looks like. Okay. For some reason, there we go. For those of you that may not be really involved with livestock genetic resources or the livestock industry, why genetic resources really underpin and drive our livestock industry. Essentially, it's these resources that we use to increase productivity within the United States and essentially the world. So, for example, if you look at dairy cattle numbers over the years, why we've decreased the total number of dairy cattle we have in this country, not because we're consuming less milk, we're actually consuming more total milk as a country, but we're doing it with a lot fewer dairy cattle now than what we've ever done it with in the past. And therefore, this kind of change is all driven by the progress, the changes we've made to the genetic architecture of the cattle that we're using. And this is really true when we start looking at a lot of our other industries. We've used here, for an example, the chicken industry. There's one broiler company that we have in the United States that produces or is responsible for the genetics of about 60 to 70% of the global supply of broiler genetics. And that just kind of gives you an idea of how important our genetic resources are to the world. We see the same sort of situation with the swine industry, certainly with dairy cattle. We just had a meeting about dairy cattle and the problem of inbreeding, genetic diversity in our dairy cattle population. And we had representatives from France, for example, that came and essentially said flat out, you know, whatever you guys do really impacts us even to a greater degree because of our genetics are really based on US genetics. And so it becomes really a critical issue for us as a country then to pay a lot of attention, do whatever we can to help maintain the genetic diversity that we have in our populations that we depend on for food security in this country and other countries around the world. As Liz noted, why in 1999, why the National Animal Germplasm was established and placed in Fort Collins, Colorado. It's part of the U.S. Department of Agriculture and the Agricultural Research Service, which is the in-house research arm for USDA. And actually, this program is specifically addressed in, as all programs really are within ARS and USDA. But essentially, our funding mandate comes directly from Congress. It's not like we have to develop proposals every 5 years to renew our funding. It's actually in the congressional language in the 1990 Farm Bill that ARS will develop systems, programs to maintain and conserve genetic resources for plants, livestock, microbes, aquaculture. And so we're really part of a bigger scheme for the entire country. While that legislation was actually passed in 1990, it wasn't until 1999 that ARS actually started a program along those lines. And essentially to kick off that program, why we had a meeting that was sponsored by the American Society of Dairy Science that invited industry, universities, entities in and started actually a dialogue. And when you look at our program and the plant program as well, why we're very much integrated, or we look toward an integrated approach, because genetic resources within the United States are really owned by the private sector. And so it's really necessary for us to have a strong interaction with industry and of course with our university colleagues as well in how we go about trying to address these issues. Our program within ARS is really small, and what we depend upon is actually how we can leverage our resources with the expertise that we have at the university level, and also trying to bring our industry partners in, which can range all the way from being large companies like Cobb Ventress, which is the broiler breeding company I was referring to earlier. They're part of Tyson Foods. We go from that scale all the way down to individual producers that may have genetic resources that are interesting or important for us to acquire and place in the collection. Um, so that's kind of the scale and the scope of the program. What we have here really is kind of a diagram of how the program works. Maybe as a prelude to that, our basic goal here is, as a repository, is to protect all breeds of livestock from epidemics to genetic diversity loss through routine use, which is kind of the issue that I was referring to with dairy cattle. Clearly, as we'll go through this diagram, this is an integrated system. It requires an information system. It requires genetic assessment and cryobiology. And all those elements have to work really in unison for us to be able to capture and preserve genetic resources. Obviously, in this, why input and collaboration with stakeholders is key. But just to give you an idea, within this kind of blue line here is the NAGP. And we're really focusing on developing information system. Of course, we need that information to go into our genetic evaluation. How much diversity have we captured within the particular breed or species of livestock or aquaculture? And then that, of course, then once we have that piece of information into kind of the cryobiology, what do we need to collect? Do we have the technologies available to effectively collect various germplasm from these various populations? All those factors then are kind of interacting with what we call this blue box here, germplasm, tissue, and collection, the collection that we have in the repository at Fort Collins. And that collection itself is very much dependent upon our interaction with the in situ populations that are held by various stakeholders. We interact with those stakeholders by having selected individuals from those groups contribute to our species committees. And essentially for every species, say like small ruminants, beef cattle, dairy cattle, swine, aquaculture, why we're going to have groups of people that come together. They'll take a look at our collection, provide advice, input as to what we may or may not want to add to the collection. They also help us with some trickier issues when it comes to releasing germplasm to industry. And that becomes kind of a critical issue for us because by the congressional mandate that we have, it also specifies that we are to give our germplasm away for free. And so we have had people come in and request material from the collection that really their whole purpose in doing so is to turn around and try and sell the germplasm to somebody else. And we kind of use our species committees as a sounding board to determine whether requests that we receive are really legitimate, or whether we all the individuals that are requesting these samples that really they should be sourcing that material from the private sector. So a very important role that those committees play in our program. Give you an idea of our collection at this point in time. You can see by these graphs actually start about the year 2000 and show the development of the collection over time. You can see at this time we have over 1.1 million samples in the collection. About 60,000 animals are represented there. 191 different breeds of livestock. And then within a particular breed of livestock, we also have specialized subpopulations that are quite unique from the rest of the population within that breed. And so we'll have for the entire collection over 300 of those subpopulations that are represented in the collection. Now, this may be, for example, if we go to a lot of universities that have poultry programs, there'll be a number of specialized lines of poultry that people have developed over one or two, potentially three scientific careers. And so we will have samples from those kind of research populations represented in the collection at this point in time. To start our discussion about Animal Grin, the information system that we developed, we had some very clear ideas of what we wanted when we first started to develop the database. We wanted it to be a real-time, web-based database that was publicly accessible. If you think, some of you may not have been employed at that time, but back in 2000, why, you could go to the internet and you could look at a lot of databases, but the information that you were able to retrieve was really rather static. It was not, it did not automatically update itself. We wanted a database that, okay, if you come in today at 1 o'clock, you're going to see certain information on the collection. If you come back at 2 o'clock and somebody has been working on the database, entering animals that have come into the collection, it's going to actually reflect that. You will actually see those numbers change. And that's what we wanted. We didn't want people to say, oh, you know, we're looking at this database and the numbers are, you know, 6 months old or 3 months old. What is the status today? And we feel that's important from the standpoint of having a lot of transparency for various people that come in and want to look and use the database. We wanted the database to contain information concerning the pedigree of the animals, genotypic information that we might have, phenotypic information, how those animals are being managed. Is it an intensive, extensive production system? And environmental descriptors as well. So we want this database to do several things for us. It has to be able to facilitate industry and research queries that potential users may have. All incoming and outgoing shipments that we have to be able to keep track of really the samples that are coming in and kind of the provenance of those samples as they come into the system. We use the collection to identify collection gaps that we have, whether we need more samples for particular breed. And of course, the collection, storage, and management of the samples themselves. Now, we will show users, the public, the total quantity of samples that we have on an individual animal. We're not going to show them where we have those samples in the facility. So that's not in the public accessible database, but it is something that the system does do for us. Give you a timeline of how we went through and developed the database. In 2000, we initiated what we called Animal Grin version 1. We did this with a group of ARS people in Beltsville. We'll talk a little bit more about that. That was delivered in about 2005, 2006, and it wasn't long after we initiated version 2. And you can see the delivery date that I've got there of 2010. And in 2015, why we went through and redesigned the web interface that we had. We've initiated a number of issues or topics as we've gone along, as we've become more interested in mapping the animals or coming from photos on the animal's capacity to store genomic data. And then moving on really to geographic information systems as well. These are the points that we'll talk about as we go through the remainder of the the talk today. But some of our early steps in developing Animal Grand, we realized that we wanted to be very transparent, and that was key for garnering stakeholder support. Now, if you think back to when we started, nobody in the livestock industry had really any experience with trying to develop these kind of collections. And if you can imagine going out to a group of producers at a producer meeting, or even at organizations like the Beef Improvement Federation, and start telling people that we were going to take germplasm from their animals and put into a repository to use in case of a rainy day, why, you can imagine probably the number of skeptical looks that you might get from the audience. And so we had to overcome those kind of obstacles, and transparency was key to that. We took and canvassed our species committee members, which in total there are about 50, and asked what data they would like to have in the database. And so for those various species groups, we have differences as you start drilling down through the program, so that it really more specifically addresses the context of a particular organism. For example, if you go to beef cattle and we want to talk about breeds, everybody knows what we're talking about. Everybody knows in general what a breed is. If you go to aquaculture, they have no such thing. And so as you go through the drill down of the program, why you'll see those differences reflected, because it's what makes sense to that particular group within the community. As I said, my programming was performed by an ARS plant database group in Maryland, and we'll talk a little more about that. And initially, the database was done using Oracle under a license held by the programming team in Beltsville. When Animal version 1 was delivered to us, now we had full input into the development of how we wanted it structured. But what we really found, or what we really got, was from our plant programmers was really something that was very cumbersome. And it was kind of like you had these programmers working for us. They had done plant work for so many years that they really didn't want to break out of their concept of how things should be managed. For example, if you can imagine, and this makes total sense from a plant standpoint, you've got a plot of ground, and every year you may plant the same variety of wheat on that plot. And so one of the questions that they came and they asked us early on was, well, do you want to have animals assigned to a particular pasture? And I was like, why? Well, it was because this reason they had seen this on the plant side. And I said, no, animals move pasture to pasture. We don't need to have that kind of information. That just kind of gives you maybe a little bit of a flair for what we had to transcend as we tried working with that community, with that experience base. The web interface for the public was rather minimal. The Oracle license was expensive. And when it came right down to it, we had a discussion in about 2006 about what needed to be changed, and there wasn't really a desire on their part to make the changes in a timely manner. And so as a result, why we disengaged ourselves from that particular group, and we started working on Animal Grand version 2, which is where we are today. Now, a key feature of that was at that point in time, why when we had that kind of final meeting with the plant group, why we had representatives from the animal germplasm program in Canada and Brazil in the meeting as well, because they had no database to use. And we decided as a group, the three of us, that we would develop Animal Grin version 2 as a joint database between the three countries. And each country would provide a programmer to work on the development team. And then there would be subject matter experts from all three of these countries that were members of the team as well, that would kind of divide or guide the development of the programming work that was done by the team. What transpired was the programmers would meet every 2 weeks, and pre-COVID, why the programmers would co-locate in Fort Collins for about a 2 or 3 week period of time per year, and often why the subject matter experts would also meet here in Fort Collins, and we would go through the work that was done, what we wanted to do, what were development opportunities for the program as we move forward. We got away from using the Oracle version to where only freeware was used in the development of Animal Grin, and that was something that we were happy to go along with, but was really key for the Brazilian counterparts, was to have only freeware used in the development of the software. When we look at, once we had Animal Grin version 2 in place, operational, why we still had kind of the old web interface that was originally done, and that's kind of gives you an idea of the upper right-hand part of this screen. You could see how units of germplasm collected over time used to be shown. We really needed a new look. We felt about 2015, 2016, we started doing that. And what we wanted was, and decided upon, was something that looked a whole lot more modern. We wanted to increase the intuitiveness of navigation as you go through the various web pages. And also at the recommendation really of the programmers that we actually contracted with a company to develop the interface. Their idea was to really have each page as kind of an educational opportunity. So as you would go to a new kind of section, there's a little blurb of text there that kind of gives maybe the uninitiated a little more of an idea of what the database is about. One of the other things that we responded to, something we didn't think was really important when we first started, but stakeholders from the field started to say, you know, what we'd really like is pictures of the animals that you've got in the collection. And so we actually incorporated that. We started adding that to the database. Really a kind of a good example are these two bulls on the left-hand side. Both of them are Holstein bulls. The bull on the left is a bull called Elevation, which was quite famous. He was probably born around 1968 or so. And the bull that you're looking at here in the middle is a bull that was born probably around 2016. And you can kind of see, without being a dairy cattle expert, that those cattle are very fundamentally different in how their phenotype in terms of height and length. And if you look at dairy cattle over the recent years, they've become a lot what the dairy people would call sharper angled cattle than what they used to be. At the far right, we've got a bull named Parisian that was one of the first Simmental bull that was imported into the United States from Canada. And so it gives people an opportunity to kind of see what those animals look like. And if you think about really all of our livestock species over the 20, 30-year, 40-year span of time, how we have changed the shape, the dimension of those animals has been tremendous. And if you think about from an educational standpoint of having students look at something like this, you know, it gives them an opportunity to look at animals that were alive before maybe they were even born, or certainly before they entered college, and these kind of things. So we feel that that's been a very useful contribution to have in the database for people to take a look at. One of the other things that we started wanting is to have more information on where these cattle came from, and to be able to visualize that. And the graph on or the figure on the left is our Holstein collection. So what you're seeing there, every one of those cows may represent multiple animals, but it represents a different dairy where the cattle that were in the collection were actually born. And so for the dairy cattle, for Holstein, we have a collection of over 6,000 animals. And so that's what you're looking at there. And when you go online and you look at the mapping, you can hover over those individual animals and it'll give you the ID of the animal. And so then you can look that up in another portion of Animal Grin and find out more information about those animals. Kind of our next phase in that was to start moving toward geographic information systems. The graph on the right, why is a product really of some work we did with Hereford, where we were looking at how allele frequencies may change for different genes associated with heat stress as you went from one part of the country to another part. And we did in fact find that there were subpopulations differences there. And that kind of led us to this next phase of trying to map our beef collection. Every red dot you see on that map is where animals in the beef collection originated from. And these different colors that you see are actually what's called the index for that part of the country. And why that's important is because it kind of tells you what kind of heat stress cattle may be under through the course of a year. Now, in our particular case here, these are average values, but you could actually go in and make that specific to, say, looking at July or August when it's particularly hot. You know, you could build a similar kind of map, plot out that, plot where the animals were, determine if there were areas of the country where you thought you may need to increase your sampling from to have that kind of genetic difference better represented in the collection. One of the things that we've also worked on is working with trying to have more opportunity to store genomic data. This was really initiated by a colleague here at Colorado State who came over and he said, you know, I've got a NIFA grant from USDA, and it says that I'm to place all my genomic data in a public database. Here's a CD with that data, so you can put it in your database somehow. So with that, that's kind of how we backed into working in this particular area. We're not interested in making a lot of tools to do genomic analysis so much as we are to try and store and capture, archive genomic data that's being generated by the research community. And once those researchers have published data, we can certainly upload that information into our system as well. What's really useful, though, is not only to have that information, but also to have some phenotypic information on those animals. And if possible, a sample of germplasm, whether that's semen or tissue, maybe blood, that from those animals as well. So it kind of gives people down the road, maybe 20 years from now, that may want to come back and take a look at a question that we haven't thought of at this point in time, where they've got a good base of information that they can move forward from. So maybe kind of a question we might ask is, has the investment in the database been successful or useful? We feel it has. Over 11,000 animals have exited the repository for use by various researchers or aspects of the industry. One of our first big uses of the germplasm we have was actually in the development of the genomic predictions for milk production, and has made a substantial contribution to the dairy industry. Those researchers came, looked at the database, decided what animals they needed from the collection to put into their research to do this development work. If we look at a couple of industry examples, why both Angus and Brangus have come to us, because we held samples on a couple of bulls that nobody else had any semen samples or germplasm or tissue samples from, that were thought to be carriers of a particular lethal disease. And they used those samples to genotype and determine whether or not those animals were carriers of that lethal mutation. In both those cases, it was found that those bulls in question were not carriers. And what that really does for breed association is allows not to genotype a whole bunch of animals. In the case of Angus, I think they said at one point why it saved them from genotyping around 30,000 animals. So these are substantial contributions that people have been able to make by using the collection. But to use the collection, you've got to have the information, the database, for them to come in and look and see what's there. Kind of our poster child, if you like, really is this lost chromosome work that we've been doing. Kind of an interesting case in point where Penn State researchers came in, looked at the database, discovered that we had Y chromosome Holstein bulls with Y chromosomes that were not present in the current population. And so they wanted to reintroduce those into current generation cows to see whether or not that would be a way of increasing genetic variability for the Holstein breed. A number of partners that they and ourselves brought into this, Select Sires, Transova Genetics as well, were utilized in developing this. And yeah, this gives you an idea of the bulls that were generated. These were the original bulls in the repository, and this is the genetic merit of those bulls. The higher, the better for what's called net merit in dairy cattle breeding. And these are their progeny out here. And so you can see that the difference between those progeny and the current bulls was quite, was small, a lot smaller than we anticipated, which is a good thing if you're bringing these old genetics out. Can they really compete against the current genetics? And the graph on the right kind of shows where the lost Y chromosome in blue, those daughters compared to the other modern daughters, we could call them, that are in the Penn State herd. And you can see that they were certainly competitive in terms of milk production. Another collection use, which is outside of the research community, why one of the largest breeder sellers of bulls in the United States came to us and requested 5 bulls from the repository. All those bulls were born before the year 2000. They mated them to about 150 cows in their operation. And this was one of the bulls that they requested, this ideal 70-75 bull. And like I said, he was probably born around 1995, maybe. And this bull is quite interesting. One of the progeny from that mating. And if you look down here, you can see that his adjusted weaning weight was 810 pounds, which is really at the high end for cattle at this point in time. And so they didn't have, a big differentiation between these cattle and current sires that were used in the calf crop. What's also interesting is when they sold this bull, why the sale average was about $7,000 per bull, and this bull they sold for $23,000. So really having economic impact on that operation, as well as how they go about changing the breeding program in their operation. Some of our future challenges that we have for database development as we go down the road, cybersecurity is ever increasing. It creates a number of issues for us, not only from the security standpoint, but really when it came to trying to work with Brazil and Canada, why it raises some interesting questions. The Canadian program had really some very stringent cybersecurity rules placed upon it, and we're still trying to navigate through those so that the system operates as efficiently as what we would like. We need to, of course, work more on increasing Animal Grin's profiles so that a lot more people can come and use it for whatever reasons they may want to. As we move forward, why we have genotypic data, but really the way I think livestock genomic work is going, there's going to be more sequence data, which is larger and presents some other unique challenges for us. So those type of things will need to be addressed. We want to be in a position where we build more tools to assess the germplasm genetic resources that we have. We've had a number of requests from other countries, Mexico, Australia, that want to use Animal Grin as well. And so how do we bring those in an equitable fashion to the 3 originating member countries? And then keeping the consortium of Brazil, Canada, the US together is an issue that we need work on as well, just because as we move down the road, there's a tendency for administrations to change, those goals to change, and people not to really understand maybe the intricacies of having the 3-country consortium that we have at this point in time. With that, just a view of some of the people that really made this happen, the programmers from the US, Brazil, and Canada as well. So Liz, with that, why I would be happy to take any questions that people may have.
Terrific. Thank you so much, Harvey. That was just far outside my area of knowledge and expertise, and was fascinating, and I learned a lot, as I'm sure others have as well. So I'm going to pause for a moment and look for people to either raise your hand, put your questions in the chat, or just go ahead. As I said, we're a small enough group, you can just speak up as well. I'll have some questions if no one else does, but wait for a moment.
Hi, Harvey. This is Matt Spangler, UNL, and I do have a couple of questions that I haven't thought of before. One is, do you guys serve as a mirror at all for samples from other ARS facilities? I'm thinking, some of those facilities collect a lot of tissue samples, and I'm just wondering if they utilize you at all.
Yeah. For example, at Clay Center, why, I forget how many tissue samples they have. They've run out of -80 freezer storage space. And we have started moving those samples just prior to COVID. And so we've brought them in. Our storage protocol is a little bit different with those because they're tissue samples. They don't need to be stored at cryogenic temperatures, which is less than, down around 197 degrees centigrade. And so we store them at -18. We don't store them at -80, but in our evaluation, that's not deteriorating the quality of those samples. But yeah, certainly with them, we've received samples that have come from Beltsville as well. When we had a location, beef cattle location down in Brooksville, Florida, why we backed up the Brooksville collection. And then when, as often is the case, things change, why the ARS decided to close Brooksville, why all those samples came to Fort Collins as a result of that move as well.
Thank you. My second question is about data, actual data exchange, be it phenotypic data or genomic data. In my experience working with some ARS facilities, the actual exchange of data is never easy simply because of data security concerns. And so simply putting something on a SFTP server isn't always the preferred route. How have you guys managed around that?
That's a good question. And that presents problems for us as well. It's not as streamlined really as you would like. So like if somebody wants to use like the genomic data that we have currently, what we're doing is you'd send us the request of what you would want. We'll go in and we'll extract that and do an FTP transfer of that data. But with some of the cybersecurity stuff we're getting into now and the like, those things are really, they seem a lot more cumbersome than what I would like for them to be.
So I had a question, Harvey. First, thanks for the presentation. I had a question about when you have a request to preserve germplasm at your facility, is there a certain amount of minimum sort of surrounding information that you require? Like we would say metadata around the sample, like is there a certain minimal amount?
Yeah.
Like, if we're going to store this, we kind of have to know something about it.
And that's a really great question because and probably really a weak point in that in some of these samples that we get, why we don't have a lot of information from, and a lot of it is dependent on what kind of species group you have. And so, for example, if you go on the dairy side, and they would be, let me call them data rich. You can get all kinds of data. On the beef side, depending on what breed group you're working with, if it's Angus, Hereford, Charolais, why good data you can get. And but once you get into small ruminants, sheep and goats, becomes less. And one that really surprised me is the universities that have these unique poultry populations, they may be selected for some particular disease, but they collect virtually no other kind of phenotypic data that, you know, we would think, okay, you're going to collect weaning weight on these calves, and you know, do you have a body weight on these birds, you know, kind of thing, and that just doesn't translate. You know, you might have some disease information on the birds, but boy, it is very difficult, but it underscores really kind of a problem that community has with maintaining those live populations. Because a dean comes in and they look at that and they say, what are you doing with all these birds? You know, we're feeding these birds, and I don't see a lot of publications coming from it. And how are the students using them? All these kind of questions start surfacing. But yeah, so, you know, in terms of metadata, you know, usually what we like, of course, an animal identification. In the case of the cattle situation, we usually can have 2 or 3 or 4 identifiers, and we'll store all those identifiers, you know, usually, for example, there's a registration number with an association. Yeah, if it came through an AI stud, there's what they call an NAAB number that's associated, and that's actually printed on the straw semen. Okay. That would come in. And so then the producer's identification that they have. So those would be information that we typically have: the breeder, the location they're coming from, the birth year of the animal would be another common piece of data that would fall into that metadata category.
Yeah, the other question I had, and this was related to your comment about, you know, especially universities convincing the university that it's value, there's value in these populations, right? Especially if you have to maintain them over long periods of time. I was thinking that if the community was encouraged to collect certain trait information or associated sequencing information, then you could say, look, but this is a great repository for specific traits that we want to maintain in the population. Like, as you said, for dairy cattle, the number of dairy cattle is going down. But as we look at changes in our environment, changes in ag practices, changes in climate, there may be traits in the population that we just haven't encouraged because of the way our ag system was set up. And as the system changes, we may need to go back and revisit traits that we really didn't prioritize before, right?
Yeah. I think we find ourselves very much in that situation. You know, if we think about climate change and heat stress in all of our species, we have not really, I don't believe, standardized or developed any common measurement, phenotypic measurement that would allow us to kind of compare across populations, kind of thing, which would be of value, I would think. And it may well be that as we really move down this road, I mean, it seems like some of the discussions, I'm hearing more discussions about what are we going to do about climate change and changing selection criteria and this kind of thing, that we may be able to start seeing those kind of descriptors coming to the top as things that are kind of best practice measurements, if you like, for various livestock species.
Yeah, thank you. That's very helpful. I had another question if no one else has one. And this was about as you said, you're mandated by Congress to provide these resources at no charge. There's, of course, industry partners whose mandate is to make money off of the animals. And I'm wondering how something like the Bayh-Dole Act functions in this space, where you might have something that's discovered on a university in a nonprofit space, and your university office says that may have intellectual property rights associated. So under Bayh-Dole, we are allowed to, capitalize on this. And how does that play into, them?
Yeah, how we've usually handled that kind of thing, whether it be a university or industry, is that we develop material transfer agreements where it really kind of spell out in general terms what's going to happen is that we will be glad to store your material for about 10 years. But after that period of time, we would like it to become publicly available. So, and we kind of take that from, there's actually a different congressional act called the Plant Variety Protection Act, where if you develop a new plant variety, why you can receive a patent on it, and it's under patent protection for 20 years. But after that 20 years, why it becomes publicly available. And as part of that PVP Act, Plant Variety Protection Act, why those companies, they send in what they call a voucher sample of seeds through Ag Marketing Service, and it actually comes to our facility, and we store that material for them for 20 years before making it part of our public collection. And so what I just described on the animal side is kind of based on what we do with the PVP.
Okay, that's really interesting. The other question I had was that I noticed that the committee, the advisory committee or steering committee for the facility has, 50 members. So how do you manage all those people?
Well,
on that steering group.
Those are, of course, broken down into kind of species groups. So there's going to be a small ruminant committee. Yeah, that's about 10 people, about 10
I see. Okay.
per group. So, and when I was discussing that, it was how they went in and helped develop the descriptors. So it becomes a manageable group to
Okay.
work with. It's not like you got 50 people in a room.
That's what I was imagining. And I'm like, I don't know how you do that.
Yeah, and of course, like, and where that becomes really important is, I think I was using the example of looking at the aquatic species. There's no such thing as a breed there. And so, as you go through the database, you're not going to see anything referring to a breed with any of our aquatic species. We've programmed a different way of showing that as you drill down. So that's kind of, how we address that.
So I'm thinking of the very large industries that you're working with. You gave the example of in the broiler industry. What is the value proposition for your industry partners, right, in working with you? What do they see as the value that your facility brings to the industry?
Mm-hmm. Mm-hmm. Yeah, their value is that if things go south on it.
Highways.
They can come and they can collect, they can use the germplasm, because of course, you know, in many instances, it's got that MTA on it. They can come in and they can pull that germplasm out and do whatever they think they need to do with it.
I see.
So, for
Okay.
example, one of our real difficult groups to work with has been the poultry industry.
Right.
And, you know, in the breeding industry, poultry breeding industry, those pedigreed populations that they have, that's really their proprietary product where they're making all their money. And the last thing they want is their competitor to get their hands on their material.
Right.
And as a result, they've been very reluctant to work with us. That said, there are people within those companies that said we should really be backing this stuff up. So if you take the case of, I think, white striping, I don't know if you're familiar with that in chicken breasts, but when you go to the store and you look at a chicken breast, if you see these white stripes through it, that's a genetic effect that they're seeing. It tends to make the breast tougher. And when that emerged as a problem in the poultry industry, if they would have been backing up their lines, like we see with beef and dairy and pigs, why you'll see, you know, they could have gotten material prior to when that emerged as a problem and started their breeding from there instead of trying to look for another way of doing the corrective mating that they needed to do.
Mm-hmm. Mm-hmm.
And so that is a good case in point, you know, of really why industry should. And it changes with management. You know, we do some backup for Cobb Van Tress, but that only occurred about 10 or 12 years after we started because there was a change in management. And they said, well, sure, we want to do this. Or, you know, we've got an agreement. We work with Smithfield, which is one of the largest swine breeding companies and production companies in the US. And, you know, you approach the management and, you know, in their case, why they say, well, why wouldn't we want to do this? And, you know, sign us up today, and it's a pretty easy thing. So, you know, a lot of variability with that. On the other hand, you know, we've got guys in the beef sector that, you know, it's to an extreme where it's extremely different. But we'll get breeders that have contributed samples to our program call us up and say, I think I've got a bull here that you should have samples on. So, you know, it's not like we have to always hunt down people to get material from them.
Mm-hmm.
So very variable in those regards.
Yeah, I imagine each industry has its own definition of perceived risk versus
Yes.
reward of participating, right? And it may be that the poultry industries it might be have to make a different calculation depending on their management at the time. But I was just thinking of right now there's an avian flu
Yes.
huge outbreak, right? And so it makes you think,
Sure.
well,
It'd be a pretty good idea.
right.
Yeah. Especially, you know, and you know, what really, when we were starting the program, early 2000s, what really gave us a leg up in getting things started, particularly with the swine community, was the outbreak of foot and mouth in the UK. And several people from the swine industry had been to the UK and saw the impact of that, and came back and became very supportive of our program as a result.
So I wondered, I was struck by something you said kind of early on in your comment, Harvey, about the role of transparency in building the relationships. And I just wondered if you could talk a little bit more about what that's looked like, or how you've accomplished that.
Yeah, I think, as I mentioned, a real important part of that has been to have Animal Grant, where people could come in and see what we have in the collection. I think that, we still find ourselves in a position, I think, where we need to explain what we're doing to a lot of different portions of the community. That kind of helps with the transparency issue, people to understand what we're doing. The thing that, the real tough thing comes in, until you kind of can actually show them why it's tough to build that kind of understanding of the program and why they should be interested or participating in it. I don't know if that really is answering quite as clearly as you might like, Liz, but yeah, it's a really kind of a hands-on kind of thing that you got to do with a lot of different groups.
Yeah, that is helpful, and I think many of your other comments as well, just in terms of underscoring what sounds like ongoing conversation and reaching out to folks all the time as well, maybe as part of that. Do you see a scenario or a future where the database is able to interact with other databases, or is it likely to be?
Yeah, one of the things that, of course, we currently have, we constructed that where essentially Canada, the US, Brazil, all have mirror images of the database. And so we can exchange information. You can hop from our database to the Brazilian database without going to a different website per se. And so that's in place. Another thing that we do is we're responsible for updating the US statistics to FAO in Rome. And so what we've done there is develop some kind of transfer protocols that allow us to move data from our database, or the Brazilian database, directly to Rome so that we don't have to re-enter that data by hand. And so those kind of options we've worked on. Maybe kind of one of the more, I don't know whether it would be obvious or not, but if you take some of these databases for genomics that maybe NIH has, we do not interact with those. And I don't know whether there's value in us doing that. That's kind of an open question on my end. Certainly when kind of a question that maybe a little more on the practical side would be, should we be doing more to interact or have those kind of a seamless transfer between our database and say a breed association, so that a user may go and be interested in looking at something that we don't have that the breed association does. Whenever you do that, though, the big question of your cybersecurity comes into play. And how do you make sure that you've got protocols so that that's not going to be a backdoor to breaking into your software?
Great, thank you.
So Harvey, if I noticed that when you were discussing the interface with the data, there are plots and pictures. I love the pictures. Do users have to, can they download data? Do they have to request to download some of the data, or is it really set up just for viewing the collection, and then if they want access, they need to go through a different channel?
Yeah, you know, and that really, we have not had somebody come and say, I'd like that phenotypic data from you. But clearly something that I would think we should have capabilities of. Now, what you can do, the awkward approach, is that you can actually drill down to an individual animal, like I was showing those pictures of those bulls. On that page, not only is the picture, but there's the animal IDs and where it came from, and there's phenotypic data that we might have on that animal, how it genotyped, say, for a particular lethal gene, and the pedigree. You can cut and paste all that. but that's not really, you know, say if somebody wanted to come in and put together a data set for some sort of analysis, it doesn't facilitate that. And what we would end up doing, and we wouldn't have a problem with this, I don't think, is that we would say, okay, you know, we'll go in and write some SQL and pull out, create a data set for a particular person to use. And that's kind of where we would be at this point in time.
Okay, thanks.
Any final questions? Okay. Well, thank you. This has been incredibly helpful, I think, for the steering committee, and I think hopefully for others in the audience as well. Yes, thank you so much for your time and sharing this with us today, Harvey. It was a pleasure, and we will, I'm going to go ahead and stop recording.